Hi, this is Mrs. LaBarbara. This is Regents Physics Chapter 7, Work, Power, and Energy Video 7. Today's topic is the work energy principle. The objectives are know definition of a system, external force toward a system, and the change in potential kinetic energy and heat. Understand work energy principle. Be able to determine the change in potential, kinetic, or internal energy in a system in which height and speed changes. Determine the amount of work done by friction in a system given a discrepancy between the starting and ending total mechanical energies. Work and energy principle. So last section we have learned energy of a system, of a closed system, is always conserved. Now we're talking about when the system is not closed. So when system is not closed means when there is external force does work on the system. Then the work done will change the system's energy. The work done by external force equals to change in system's total energy. This is the work energy principle. And the E total is PE plus KE plus Q. So the work done by external force is change in PE plus change in KE plus the Q. External force is applied force. That means you have to push or pull, exert a force acting on a system. What's a system is any set of objects involved in a problem. So let's take a look at this question example again. This equations again. What is the work done by external force? That is applied force times distance. That is work done by external force. Delta P, that is change in potential energy. That's change is mg times change in height plus 1/2 k change in the elongation squared. Delta Ke is change in kinetic. That means it equals to 1/2 mvf squared minus 1/2 mvi squared. Q is internal energy. Internal energy is the work done to overcome friction. Let's take a look at this example. In the diagram below, 450 joules of work is done raising a 72 Newton weight, a vertical distance of 5 meters. How much work is done to overcome friction as the weight is raised? So here is the work done by external force equals to change in PE plus change in KE plus Q. So work done by external force in this case is 450 joules because it's given over here. Change in PE is mg delta H. Mg is 72 newtons. It's tell you 70 Newton weight. Okay, that's mg. Delta H is final height minus initial height. You have 360 joules. Ke equals 0. How do I know? Because you start from at rest. When you lift this high, it is stopped. So it's again at rest. So change in Ke equals 0. What is Q equals to? Plug everything in, you have Q equals 90 joules. So work done to overcome friction is 90 joules in this case. Now here is a block weighing 50 newtons is put to the top of an incline that is 0.2 meters above the ground as shown. If 4 joules of work are needed to pull the block the full length of the incline, how much work is done against the friction? So this is a work energy principle. Work done by external force is change in PE plus change in KE plus change in Q. Change in PE is final minus initial. It's 3 joules. The work done by external force is 4 joules because it tells you Ke equals 0. Before you push it, it was at rest. After you push it, you stopped. It's again at rest. So what is Q equals to? In this case, Q equals to 1 joule. So work done to overcome friction is 1 joule. Another example. A box of mass 0.04 kilograms starts from rest at point A and travels 5 meters along a uniform track until it comes to rest at point B, as shown in the picture. So determine the magnitude of frictional force acting on the box. Well, that's start from rest, ends at rest. So as you can see during this process, potential energy is lost. Where is that potential energy go? We know total energy cannot be gained or lost. That potential energy actually changes into heat. And what is heat? Heat is the force to the work done to overcome friction. So let's use work energy principle. So that is Q is force of friction times dy. Why do I use this instead of Q? Because you're asked to solve what friction is. Work done is 0 because there is no applied force in this case. Change in potential energy, final height minus initial height times mg, which gives you a negative number, negative 0.1177 joules. Ke equals 0, you start from at rest and end at rest. The length of the path is 5 meters, solve for F, friction force. So plug everything in, work equals 0 equals to change in potential, that's a negative. Change in Ke is 0 plus FF times D is 5. You can solve for FF, will give you 0.0235 newtons. And that is a magnitude of force of friction is 0.0235 newtons. Let's take a look at another example. A 25-gram paper cup falls from rest off the edge of a tabletop 0.9 meters above the floor. If the cup has 0.2 joules of kinetic energy when it hits the floor, what is the total amount of energy converted into internal energy during cup's fall? So let's use work energy principle. The work done by external force is change in PE plus change in KE plus Q. There is no applied force in this case, so this is 0. What is change in PE? Change in PE is mg delta H. You start from 0.9, you end it with 0, so change in PE actually is negative 0.221 joules. What is change in Ke? That's a final minus initial. Final is 0.2 joules. You already know initial is 0 because it starts from rest. That's 0.2, so that's change is 0.2 joules. What is Q equals to? We'll plug everything in. 0 equals to change in potential plus change in kinetic plus change in Q. So you can solve Q equals to 0.021 joules. So total amount of energy converted into internal energy or thermal energy during the cup's fall is 0.021 joules. So this is energy conversion. Basically, initially you have positive 0.021 joules. And at the end, you only have 0.2 joules of mechanical energy. Where did the rest go? The rest is converted, 0.021 joules is converted into heat. Another example, so a block weighing 40 newtons is released from rest on an incline 8 meters above the horizontal. So over here is 8 meters. As shown in the diagram, if 50 joules of heat is generated as the block slides down the incline, what is the maximum kinetic energy of the block at the bottom of the incline? So again, work done by external force is change in PE plus change in KE plus Q. So again, there is no applied force. It's just gravity and friction. Those are not applied force. So work done by external force is 0. Now change in PE is final height minus initial height. Final is 0, initial is 8. So change in PE is negative 320. And we know 50 is generated to heat. What is the final kinetic energy? Let's see, Ke is final kinetic minus initial kinetic. And initial kinetic is 0 because the block is released from rest. So what basically delta Ke equals Kef. What's that equals to? You plug everything in, you have 0 equals to negative 320 plus 50 plus Kef. So Kef has to be 270. That is maximum kinetic energy at the bottom of the incline, 270 joules. Another example. So as shown in the diagram, the student exerts an average force of 600 newtons. So this is applied force, 600 newtons on the rope to lift a 50-kilogram crate a vertical distance of 3 meters. How does the work done by the student compare to the gravitational potential energy gained by the crate? So the work done by the student is force times distance. So here is a force applied 600 newtons. What's the distance the student has to pull? In order to lift this object 3 meters, the student must pull 3 meters. So the work done by external force has to be 600 times 3, give you 1800 joules. What is the kinetic energy change? I mean, what is the gravitational potential energy change? That equals mg delta h. So delta H is 3 minus 0. That gives you 1472. So you did this much work, then you ended up with that much of kinetic energy. So how do they compare? The student did more work. How much work? Over 300, about 328 joules more work than the gravitational potential energy gained by the crate. Another example, a person does 100 joules of work in pulling back the string of the bow. What will be the initial speed of 0.5 kilogram arrow when it is fired from the bow? So again, work done by external force, because that's how much work you have done, 100 joules. That equals a change in potential plus change in kinetic plus change in Q. Let's see change in potential. So before you pull in the string, there is no potential energy on the bow. After it's released, it still have no potential energy. So there is no change in potential. But before you did work, the kinetic energy is 0 because it was at rest. After you did work, this kinetic energy has increased, equals 1/2 mvf squared. And this Q is related to resistance or friction. And that was not mentioned in here, so we say Q equals to 0. So the work done by the external force by you is 100 joules. There is no change in potential. There is no Q. KE is final minus initial. Final is 1/2 mv squared minus 0. So this is just 1/2 mv squared. And that equals 1/2 0.5 times VF squared. The question is, what is VF equals to? So it's 100 equals to 1/2 times 0.5 times VF squared. And you should have VF equals 20 meters per second. That is the speed of the arrow when it is released, when the bow is released. That's it for today. Thanks for watching. See you next time.